Hello, Favor. Can you hear me?
Good evening, Ademola.
Good evening. How are you
I've
doing?
not seen our class before.
Yeah, I've been taking today's session actually.
Oh, okay. Oh, okay. You are the tutor for today.
Yeah,
Welcome, sir.
thank you for having me. You can hear me clearly, right?
Yes, I can hear you well.
All right. Sorry, could you like run me through how the sessions are always like? Because I think the recording is on. I can just like start right away. Can you guys hear me?
Yes, I can hear you.
Okay. So I'm ready whenever you guys are ready.
Good evening, everyone. Darlington is not actually free right now, so this is Shedrack. So basically, I think Kevin is Kevin on the call.
Yeah, yeah, I can hear you.
All right, guys. So basically, we're already 10 minutes in, so I think Kevin should start already. Like I already started the recording. So good day everyone. Your tutor for today is Kevin, basically, and I think this is the first time he's going to be joining you guys. So basically, I'm just here on behalf of Darlington to do a proper introduction to the new tutor that I'll be taking you guys today. So Kevin, you can actually proceed now. We're 10 minutes late already. If that's fine by you.
Yeah, yeah. Good evening, everyone.
So basically, I'll be here to assist you with admitting personnel and controlling the
All right.
attendance. All you just have to do is to go through. Okay.
Yeah, yeah. I
All
get.
right. Thank you.
Yeah. Good evening, everyone. Um, I'm Ademola Kelvin, um, blockchain engineer and a contributor on StackNet. So I'll be walking you through testing with Foundry, just to like get a little bit of background on what we know about Solidity so far. Right? We all write Solidity, right? Or have some level of experience with it, right? So, can you guys see my screen? Yeah, so I don't have a slide here, because the contents um to be taken are quite much. So just like get right into the documentation, right? So um quick one. Can are we guys following? I need feedbacks, please. Okay, so
Yeah, we are following.
the all right. So while developing with, I just want to like get some little backgrounds on like development experience. What toolings are we familiar with in writing smart contracts? Anyone? Okay. So so just as we know, we have like several tools to write smart contract. For smart contract development, you have Truffle, which is created already. Also, you have Hadat, and also you have Foundry, which we'll be taking a look at today. So basically, what is Foundry? Foundry is a smart contract development tool chain, and if you're conversant with Hadat very well, you know that gives you capabilities of writing your smart contract, right? Um, Testing the smart contract, and also gives you an environment where you can write script to either deploy your contract or interact with them, right? And it also gives you uh, the the added feature of deploying a smart contract, like forking a local network and creating an instance of a local blockchain in your machine. And also, an additional feature is that you can fork a live network, like get a snapshot of the main network, which is Ethereum or any other net or any network you want to like have your contract deployed to. So this is the same capability Foundry gives you, but Foundry is written in Rust, which means there's more. It is lightweight and much more faster compared to Hadat. And then when developing in Hadat, right, you write your contract in Solidity, but you're scripting and testing in JavaScript. And why can't we just have everything written in Solidity? These are the added features that Foundry gives you. So your contract is in Solidity, your testing is in Solidity, and your scripting is in Solidity. So basically, what we're doing firstly is, please, I would like for the session to be interactive, and if you have any question along the way, please feel free to call my attention to it. So what we'll be doing basically is we'll start by setting up the development environment of Foundry. So installation, I have Foundry installed already, but I uninstalled it. So basically, we'll be setting it up from scratch, and I believe that we are all using what do we call it? We are using Linux, right? Because I'm only like familiar with the setup of Linux. I don't use Windows or Mac, but it should be compatible with either Mac or Linux, whichever one. So if you want to follow along, feel free to follow along with me. So so to install Foundry, right, you have to like run this command. Hope you're telling me around the following command. So I'm going to paste this and it's going to install the necessary dependencies for me. Yeah. So it is done installing. So it says simply run Foundry up to install Foundry. So if I should run Foundry for Foundry for okay. So why I got the error initially is you will know that I believe we're conversant with shells, right? You know that you have the bash RC and then you have the you have bash and then you have ZSH. So this configuration is for bash, right? And my terminal was on ZSH. Hence the reason why it failed at this point. It said Foundry command not found. But I'll be showing us how you can like add the path it's going to create for you to your ZSH file. So let's just wait for the installation. Yeah. So while it is downloading little information, so this is the repository. You can see it gives you some details here. This rep points to the repository of Foundry. This book points to the documentation. So the documentation of Foundry is called Foundry book, right? And if you want to like join the conversation, I'd advise you join the conversation here, so you are able to like network with top level engineers as regards any issues you'll be facing while developing, and also you can make contributions um, in their conversations too. So okay, yeah, it's done installing, and if I should run Foundry version SafeForge. Okay, so I've switched back to ZSH. So if I should go to my okay, let's see first. Okay, running Foundry up itself installs um the latest nightly precompiled binaries. See Foundry up for. So I'm done, but then I have it configured for Bash, not ZSH, because I prefer check to ZSH. So all you need to do is come here, open like come to your own directory. This section will be hidden by default. So you have to like come there and click here, show your dim files, go to batch RC. So underneath here, you see that it has added the configuration for Foundry for you. So what you need to do is just copy it. And this is if you prefer ZSH as your development environment, and you paste whatever you have here, save, and start your terminal. Yeah. So I created the repository earlier. what do you call it, say folder earlier. So this is the directory in which we'll be having our project. So we've installed Foundry as on our PC now. Before I move on, do we have any question? Any question so far about the installation? All right, I'll take that as absence of question, right? So back to the documentation. Right, so let's see how we can get started with Foundry. So here is the okay. Let's just set up the project first. So creating a new project. So creating a new project now, all you need to do is run forge in it, then your project name. So if I should call this blockchain union Foundry demo. First demo. So it's creating the project stuff for us now. Yeah. So cd into blockchain and code. Yeah. This is now. So what we did earlier was create a template for our project by doing forge init. Let me just run us through the command. I did forge init, then your project name. Basically, what we did here was if you want to initialize a new project, forge init, then you have to press specify your project name here, right? So that was what we did. And then it installed the necessary dependencies for us and set up the project with the required contents, right? So then what I did next was open the project. Now taking a look at the project directory and the setup. Please, I believe we are following because I'm not getting any feedback. I want to be sure there are no confusion or I'm not like going too fast. Any questions so far before I proceed? All right, awesome. All right. So in here, you have your Forge STD. This Forge STD basically contains configurations about um, um, contains some configurations like VM, um, how to like manipulate storage, test, and a lot of other things you can use. These are inbuilt functionalities built for you straight from by Foundry itself, right? And if you want to add external dependencies, you're going to like see it in this what do you call it in this lib directory. So looking at the okay, yeah, so script contains your script. I believe we are familiar with ADAT, where your script basically you want to like run deployments, deploy to either a local network or deploy to live network or things like that. So you basically run the script for this. And another thing is your source folder contains your main project, right? And this test folder contains your uh, what do you call it? Contains your tests. So if you should look at this project in your SRC, you have counters, right? Compile successfully. Yeah, okay. I don't know why these squiggly lines are here. Basically, this is a counter contract and it sets a state variable number, right? And then you have a function sets number that initializes the number, right? And then you have function increments number. So this is a simple contract, and then for it. But then before we go to like getting a understanding of the test, let's see the Foundry book itself. So basically, there are two approaches in which you can use to like write tests. One, you either you write unit test or then you write integration test. Unit test basically, um, just as you have your main project here, you can just like append your test at the end. Yeah, test each functions, right? Um, but integration tests involves you like separating, having a separation of concern where you have your main project and then a folder for each test, just as that's been done here. This counter.sol is your counter contract, right? And also this your counter t.sol is your test contract. So one thing you need to like know with Foundry is that you have your test in test folder, and then for Foundry to recognize that a file, right, is a test, it has to be appended with the T, where you have the name of your test dot t dot sol. Whereas if you're writing scripts, it has to be um, the name of the script dot s dot so this is how Foundry distinguishes between the script and also distinguishes between a test. So we'll be taking a very simple example, right? Let's go straight to writing test. So another thing Foundry does for you is it gives you functionalities whereby you are able to like do cheat codes. What we mean by cheat codes is like it provides you with um like some inbuilt functionality where you can I say things like you prank, roll, roadblock and things like that, like things you normally like do during testing. Take for instance, you write a staking contract where reward is by every block, right? So your reward is calculated at every block height of let's say 100, right? So while testing, how do you test for this? You can't basically like you wait till the network sort of like executes like reaches finality for 100 blocks, right? So what you can do is you can use this cheat code to like roll. You can roll or like roll that block, right? You specify the number of blocks you want to roll by, and also if when you're dealing with time, say you have to stick for let's say 24 hours, right? You can't wait for that 24 hours before you test your contract, so you can warp time. So these are like the input functionalities Foundry sort of like gives you. But we'll start with like the lowest concept here. So there's a really good repository which I'll be recommending for us to like check at the end of this session. The session will be quite brief actually. So it contains a lot of projects, right? And it has some YouTube videos in which you can like make use of. So I'll start by creating simple project. So before we proceed, any question? In the absence of like in the absence of anything, I believe like we all understand what we are discussing here, right? Is anyone following along, trying to like set up his or development environment? Any issues at all? Could you unmute your mic and kindly give me the feedback? I can't decipher anything from the thumbs up or the thumbs down you just like showed now.
Yeah, I was just going to say that I'm not with my system, so I'm just like following, just listening.
Okay. Quick question. What do you understand by Foundry? Like with a little context we just did now.
Okay, it is a tool like hard hats that allows us to do some scripting and testing. But the main difference is that you can use Solidity instead of JavaScript to do the tests and scripts, testing and scripting.
So I don't like assume you have like a grasp of how that try to develop with hardats, right? Um, some Tochukwu, are you still on the call?
Sorry, what did you say?
I said you develop with hardats, right?
Yes, sir.
All right. Please, I would want to like call just basically my own approach to taking classes. I love for classes to be interactive because the whole silence seems very weird. It seems I'm the only one in class, so I'd want some sort of like feedback mechanism once a while. So I would have to like be calling names to like actually get if you following the call. Yeah. So what we were about doing was like setting up a simple contract. So what I'm going to do here is create an interface.sol. I'll also create an ERC20.sol. So this project has been written already. So I'll just change a few things here. So I'll change this from internal to public. I believe we understand what um, this function visibility means, right? Is favor on the call? Okay. Harry,
I
okay,
think
are you on the
that's
call?
it.
Harry, okay, are you on the call?
Yes, I'm in the call.
Yeah. Could you share insights with us, like what the public function visibility means?
Okay, so depending on the visibility of our functions, we want to let the blockchain know that okay, that certain functions are available to users, and some are not. Like if it is tagged public, then it is available to users. Everyone can view it on the blockchain. If it is tagged private or internal, it is not. Yeah. I think external and public should function the same way. If I'm
Okay,
correct.
and what? Okay, awesome, awesome. Yeah, great response. You might want to like be more precise as regards like your what it's. Yeah, so interfaces. So if you want to like build a project, what we'll do is run forge build. Okay, okay. So if I should build this contract now, I should build. Yeah. So we understand what building a contract means, right? Yes or no?
Yes.
All right, awesome. So now we have a simple contract here. We have an interface does so we are specifying interface. We are all familiar with ERC20 tokens, right? Or the ERC20 standard. Yes or no? Yes or no? Please, someone should respond.
Yes, you are.
Awesome, awesome, awesome. So basically, we're like defining an interface here, as simple as that, and then we are inheriting the interface here. So this is a simple ERC20 contract whereby you're setting your constructor, you have your name, symbol, decimal, and then you have transfer, you have approve, you have transfer from, you have mint. So the mint were 8 and
Yeah, well,
before.
yeah, with it.
Exactly. Okay. So to create test for this, we have to like call it ERC.t. So so here are a little bit of things you have to like pay attention to. Firstly, when you're writing tests, it follows the same approach, right? You still have to like specify your license identifier, XPDX, license. Just copy from here, yeah, right? And also you have to so remember this forge std in this forge std test. So this contains every functionality for testing that Foundry exposes to you. So you have to like um, bring it into your project and also inherit it in your project. So I'll have have it import. Then the project you want to test exactly, you have to like import it from shops. Yes, 20. So, what I will bring in there. 20. Then we have contract. Let's see, 20. Test. Test. Let me see the builds. Okay, yeah, awesome. Okay, so when we want to, what we want to do now is like be able to test this contract, right? This simple contract that we have. And before you're able to like test the contract, you have to deploy first. But then, how do we go about deploying the test? So we have to like create an instance of that contract. So you have ERC20, then you have let's say public, then you have token. Now we have to set right have a function that help us like deploy our project that deploy this token. So you have function setup, call it public. So what we are going to do now is say token is equals to new ERC ERC20. And we know that our okay, we know that our token, our ERC20 contract expects some parameters at the constructor level, right? So what we're going to like do is expecting a string last call name. Let's mark it as option name. Okay. And then we have string simple. Let's go simple. Let's just call it BT or something. BT. And then yeah, the decimal should be constant. And so we're going to like pass in these parameters here. We're going to pass in the name underscore name, pass in underscore symbol, and also let's call the decimal 18. Alright, so this is our setup now. Now we've deployed this contract here. So when you're writing tests, right, to for Foundry to also know that a particular function you want to test is a test, it has to like start with the name test. So let's say test token is underscore token name. So you want to like text the token name here. So we have token that's okay, so we want to test the token name. So let's just assert equal. So assert is like comparing the left hand side to the right hand side, and what we want to compare now is in this case token dot name is public. Assert that token dot name is equals to underscore name. So let's run forge test. Okay. Done. Oh, okay. Our test is outside No one was even following to correct that. So the test file I created was actually outside the test directory. So it should be in the text directory, right? So let's see. Let's try again. So the test you executed initially was test for this counter dot. So if I should run this test now, I should run test for both of these files. But I'll be showing us how you run test for a single test file. So if I should run, yeah. So you can see that. So another thing that Foundry gives you is sorry, I hope this screen is not like too, is the font okay like this? Or should I reduce it a bit? Alright. Yeah, so let me just reduce it a bit. So I ran so we have two test files, right? So you have counter t.so, you have your ct.so. And basically in the ERCT.so, we can see that we're testing for, we firstly did the setup to deploy the contract, and then we are testing for the token name, right? And test token name successfully passes. So when you have multiple tests, but then you want to run tests for a particular project or a particular file, what you just need to do is test.match. Yeah, go ahead if you have a question. I thought someone was raising up his hands. Okay, yeah. So to run tests for this ERC 20 token alone, right? So you just need to like specify, still follows the same approach, forge tests, match contracts, right? And then the name of your test. You have ERC 20 test, right? So if I should run this, it's going to execute for, let me clear this. It's going to execute for just this alone, right? So you're able to like get the content of what you want exactly. So um so let's test for the name. So let's also test for the symbol function. Test symbol. Symbol specify public stats. Remember, a stat equal compares the left hand side with the right hand side. So basically, what are we testing for in this case? We want to test for the symbol, right? Okay, symbol. And what is the token symbol? We have underscore symbol. So let's also write test for the token decimal. So we have public. So assert equal, right? Token dot decimals. Ensure that decimal is 18. So if I should run this test, you can see that those three test cases pass. So going back to the documentation, there are a number of things I want to like show us. So if you read through this documentation now, it's like self-explanatory and direct, right? So there's something called yeah. Let's check. So cheat codes. Now we are still going to come back to cheat codes, right? Cheat codes basically like give you functionalities where you can let's say something like impersonate, do like some complex what's the main word now? Gives you sort of like a spice to your project, right? Where you're able to like test case scenarios. Because basically, what you're doing testing is you're testing for different use cases of okay, what if I pass these parameters into my contract? Does my contract actually like return this content, right? Like you have multiple scenarios where you're testing for. right? So this cheat code gives you the functionality and gives you some functionalities where you can like manipulate time, roadblocks, and things like that. So understanding traces, what traces basically means is it gives you like a full explanation of what is going on in your contract, right? First, you can produce traces either for failing test or for all tests. So basically, what you're trying to like get is just to like get your test verbosity, right? So if I should run this test with dash VVVV, as you can see here, with four V's, it's going to, let's try with three V's first. It's not going to do anything. But with four V's, it's going to generate an execution trace for you. And what do you see what I mean by execution trace in a minute? Yeah. So this is what we mean. So this is a static call, is a read call, right? It's showing you that it's testing for does
One
anybody have a
question.
question? Yeah, go ahead.
Yes. Know what that minus VV, what does it mean? Like, what's the command?
That's
What's
what
it for?
that's what I'm explaining basically. It shows you the verbosity of your it shows you the execution trace of your tests, right? So if you don't specify it, you can see. Let's go back to, let me clear first. Clear. I should run forge tests, match contracts. You understand what this match contract means, right? I'm trying to execute this particular test alone because if I don't have it, it's going to execute both the test here and the test here, right? So if I should run this now, you see, you just see that the test passes. It says test token decimal, test token name, test token symbol, chickener, no additional informations. But as you write your code will not be this simple, right? There are instances where you have to like send, say, this is taking a liquidity pool, where you have interaction with pool A or pool B, right? You have to like you want to see the execution of those things. Who made so call at so time and things like that. So what this dash VVV gives you is it gives you like the trace, the call trace, right? So if I should execute this now, right? So you can see the call trace now. Basically, you're saying that okay, ERC test, it calls this test something, right? And then it executes this um, function called decimal. That static call. So you still like get more insight about what this execution trace means as we go ahead. But basically, it's showing the execution trace that okay, this function was called, and this was the output it gets, and it's a static call. Like it's not something like really like modifying state like that. So you can see that the test is passing. So what if you want to like check for gas, right? You want to like know the amount of gas each test sort of like consumes. If it's a requirement for your project, it's not all the time that you check for, what do we call it? That you check the gas report. So you have I might not want to like include this dash dash gas report. So if I should run this now, it's going to show me the amount of gas each function execution sort of like consumes, right? So deployment cost, deployment size. So function names, minimum, average, median, max, and number of calls. So for decimal now, so this is the cost for deployment. Remember, we had to like do setup here. What's the stuff? Okay, yeah. We had to like do setup here, right? So this is what it cost. This is the amount of gas it cost us to deploy, right? And then the function executions, you have decimal when you execute. Oh, fetch for me the token decimals, right? This is was the minimum gas it consumed, and then symbol, and then make address and things like that. So what more can we test for? Now let's go to minting. Say I want to like test mint. So now um, I want to like create an helper function. I have it somewhere. Yeah. Okay. Import function. So if you want me to like push this repository at the end of class, you can just like let me know. So yeah, so what we have here is a bar function. Basically, what I want to do is that I want to be able to like have an instance where I'm going to like set address user one, and if I call make address, I'll be able to pass in the name here, say um, user one, let's say address user two, make address user two. Right? So let's look at what this make address is doing quickly. So it's a function make address that receives what do you call it? A string memory name and then returns to you an address. And what you're doing here is you are caching and maybe are encoding this. And I don't need to like start getting into the byte size of addresses. You know that addresses are 20 bytes and then the equivalent in unsigned integers is like 160, right? So to like get the equivalent of an address in this case, you have to like go through this process, typecast, like cache it and then typecast it to a unit 160. Then this VMW build, um, it is exposed to you by Foundry itself. But basically, it it enables you to like be able to like generate addresses. So we want to um mint to a particular address, say tests mint token is user one public. Now, what do we do? We want to mint, right? So let's say token dot mint. Who are we minting to? We have user one. Also, let's say we want to mint 1,000 of this token to user one. And inside this function, we have to assert equal that um, token dot balance of who user one in this case is 1,000, and you want to assert that assert equals that token dot total supply is equals to 1,000. Now let me just go back to the contract. So when you mint, right? When you mint, you have your function balance of being added. But when you mint a particular address, you have the amount being added, and then you have the token total supply being increased, right? So we should understand that when we mint this user here, 1,000 what's the token name again? BNT token to user one. So user one should have 1,000 here, and the balance of user one should be 1,000, and the total supply should be 1,000, right? Just as we've seen. So I'll clear this and run the test again without gas reports. Let's see dash dash. Let's use the verbosity. Inspected. For this. So you can see the traces, right? So let me clear this. Okay, yeah. So for the person that asked earlier that, oh, what does this V stuff mean? So you can see that this gives you like a more interesting use case, right? When the token was minted, it gives you that, okay, user one is this is so address, right? And this amount was minted to that person, right? And it gives you like the emitted event. So you're minting from zero address to this user this amount, and then you're checking balance of this person, right? So basically you have a more complex function, right? Say in your function you first send to a person, you send to a contract, then you send to one person, like based on the logic you give of smart contractors are not like one way. It is based on the writers and the engineers logic, right? So, but the basic idea is going to give you the function trace, the core trace of the how those parameters were executed and how like the whole mechanism stuff like works, right? How like we are following. So say I want to like do something now. Say okay, we've tested for user one, right? Okay. So let's say function, let's say you want to like test transfer to token, transfer to user two. Now, so I want to like ask, Favor, are you on the call? Franklin, is Franklin on the call? Yeah, go ahead, speak. Okay, now no problem. Just on this live, ask us something. But basically, when you know when you want to transfer ERC20 token, right? You know you have to like sort of like give approval first, right? So say user one wants to send let's say 20 200 token to user two. You know that user one has to this has to approve user two first before sending before receiving. Has approved user two first. So this is where pranking comes in. So we have something. So pranking basically needs you to be able to like say let's just see the cheat code from Foundry book itself. Hmm. The other section of cheat codes. So you have a number of them cheat code references. Yeah, so let's see. So these are the available cheat code you have. So you have WAP, you have Gent nouns, you have a number of them. I'm searching for prank. Yeah, start prank. Set up subsequent calls. That means the sender to the input address until stop prank is called. So let's check our contracts. So we okay, right. So we have VM dot start prank. Who do we want to prank in this case? We have user one, right? And we want token dot approve. Who is the spender in this case? User 2, right? And how much do you want to approve for user 2? We have 200. So we're going to do VM dot stop. Now we have to like prank user 2 in this case because it's user 2 that wants to like send the funds to start prank user 2. And we at some point we have to like stop the prank. So what do you want to do here? We have token dot transfer from. Now who's the sender? You have user one, the recipient, you have user two, and then what amount are we sending? You have 200. So here we want to like assert equals dot token dot if this transfer is successful. So the balance of assert equals taking that balance of this person user two to 200. Alright, so let's execute this and see if we are correct. Okay, yeah. I didn't declare it. Does anyone have a question?
Yes, I have a question.
Yeah, go ahead.
I, I want to know why we already using online 52. Why we are already allowing user 2 and not user 1.
I don't get your question.
Like you say that we have to assert, and then it's only for the balance of user 2,
Yeah, we're
but it's
checking
not
the balance
applicable
of
to
user
user
2.
1.
We're checking the balance
Okay,
of, okay. We're checking the balance of user 2 here. So let us also check the balance of user 1. Then set the user 1 balance. So if you send, user 1 has 1000 initially, Abi. If you send, this might likely fail, but let's see first. Um, user 1 has 1000, right? So you should have one plate left. This is going to fail, but let's see first. Yeah, for which of the tests transfer from? Okay, so let's take this int function to set up. Oh, okay. Yeah. It's 1000 that we have. So another important thing of the execution trace is you can see that it's giving you the logs that is like giving you like a feedback mechanism that oh, emit log A is not equals to B. A is not equals to B, not satisfied. That on your left you have 800, on your right you have 18. I don't know. Do we get that? So if I should execute this should like pass successfully now, right? So initially, let me revert back to the former state of what I have. Yes. Yes, let me revert back to this. Yeah. So, please, I want to be sure that you are with me. Are you following? Okay. Okay. So, remember that when we set up the project here, we initialize with the constructor parameters, right? And for each call we have here, it is within the context of this function. So anything, so when I mean here, right, it's not accessible at this like this meeting is only within the scope. That was why we experienced this underflow or overflow error. You can see that we have arithmetic overflow, and I believe you understand the concept of overflow and underflow, right? Such that at this execution call, user one's balance is zero, so he has nothing to give out. So basically, what this execution call is telling us as is that you're transferring like the execution you're trying to perform is invalid. But if you come back to line 34 to 38, and I take this mint token out, right? I set it to this in my setup. This setup is global because from this from this token, I'm able to access other functions, right? That means if you should mint here, obviously the state of the balance of the user should like be maintained all through the function calls, right? So it's no longer outside anymore. And remember, it was 1,000 of our token that I minted to user one. So it's wrong to like query the user one's account for 1 8. Instead, 1,000 minus 200 should give 800, right? So let's see our execution now. Yeah, so this is the execution trace I was talking about that gives, so test transfer to user two alone, you can see the whole like execution trace going on inside. So it starts by saying, um, can we all see my screen? It starts by
Yes.
saying, okay, yeah, we start by saying test, okay, this test now, test transfer to user two. We start by saying, okay, user one, right? We're pranking user one here. So you know that when you want to like transfer a token, you have to approve either the contract or the spender. In this case, it can be the contract, it can be the person you're sending to. So we have to like approve user two, which is the spender of this amount, and it emitted the approval what do you call it, event. So you have owner is user one, spender is user two, and then this is amount we give the person. And then remember that your approval is going to return a boolean, which is true, right? So um, the approval here is true, and then it stops the prank. Then now starts the prank for user two because it's user two that is going to receive their funds, right? So now it's transferred from fixing the sender, the recipient, and then the amount. So who is the sender in this case? The sender is user one. The recipient is user two of how much 200 BNT token, and um, it's going to emit the transfer event. And basically, we queried the balance of these two individuals, user one and user two. That okay, assert that their balance is 800 and their balance is 200. So let's do one thing. Uh, okay, calm down. So so now that we know that, we should be able to like write a function to like check that, say the total supply should be 1,000. Okay, let me just bring this one out of here and just add it here. But I believe like we're getting like the rough idea of everything, right? So if I should test this now, either your user one or user two should show that the total supply is, let's have the best report. The total supply is 1,000. So this execution should go well. So you can see like the execution call and things like that, the number of times those calls were made, and basically, so what this sort of like gives you is you can add this to your documentation, right? I think they should be able to like generate this as a documentation. You'll have to like look into it and see I think it's possible, but I can't remember the exact command. So that's it basically. So you can like go ahead and test more, like add more use cases. So now what we are moving on to next is say, oh, are we able to like what do we say? How do we say it? Add dependencies to our projects, right? Say external dependencies to our project where Foundry. Yeah, it's possible if you come to the section of dependencies. So just as you have it in adults where you have to like do maybe npm install or yarn install or things like that. So the way Foundry works is it use GitHub submodules, right? And what I mean by GitHub submodules is you reference whatever you want to download there on GitHub, and it's going to like make it as a submodule for you. So say we want to like use Open Zeppelin in our contract now. So it says Forge means dependency. Forge manages dependency using Git submodules. You can like look into what submodules means by default, which means that it works with any GitHub repository that contains a smart contract. To add dependency, run forge install, and then you specify the name of the repository you want to like work with. So let's say we want to like use OpenZeppelin in our contract now. OpenZeppelin, yes, it's waiting. So we come down to OpenZeppelin. Yeah. So all you need to do is just grab the content here, right? Let me clear the terminal. I do remember I said forge install. Right, so just so this is all the copy. Just remove this and yeah. So I have a little bit of issue from my hand. You should not experience this. It's because I haven't like cleaned up my repository. My work repository is sort of like dirty. So I have to like run um forge install this dash dash new comments. So what I'm saying is I don't want to no, 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 comments. Okay. Yeah. So my tree repository is like messed up. That was how I was getting this error. So the way I can bypass that is to just to no commit. That is, I'm not making any commit at all. So it's going to like download the necessary dependencies for us. So when you want to like add a dependency, you should like be straight away out of the box for you. So you wouldn't have any issues. Okay. Oh, sorry, I was installing in the wrong project directory. These are the stuff of having like multiple VS Codes. So, so let's just do forge install. Should I have any issues with this? Okay, I still have the same issue. No comments. So it's going to like install the dependencies now. But the dependency is installed is OpenZeppelin, right? And there's something I want to show us in relation to this. Any questions so far?
So I have a question.
Yeah, quiet.
Okay, you say that there is an error when you want to push it to your GitHub account. No, I didn't actually get it.
What I was saying is, remember when I ran, say we want to install dependencies, right? You run forge install, open Zeppelin, Zeppelin contracts, right? You get it up to that level, right?
Yes,
Yes. So
yes,
the cause of this error is like my working repository is like my Git tree. I need to like clean it up, right? So um, to be able to like install the dependency I need without having to clean it up. That was why I had to like add this no commit command. So this is specific to my machine alone, not to your own machine. What you need to like just run is run forge install, then the repository in which you want to work with. Do you get?
yes.
All right. And whatever issues you run to while trying to like set up your stuff, you have to like find solution for that. So if you check into your lib, you can see that you have Open Zeppelin contracts here. You have Open Zeppelin contracts. You have access, finance, governance interfaces, tokens. So basically everything you have. The things that's been provided to you as a package, as an npm package or a yarn package, right, is what you're installing using the using GitHub modules um, in Foundry. Now, with that done, right, you have to like be able to like create an easier pathway to your project if you want to like install like once you've installed the dependencies, you want to like reference them. Say you want to use the ERC20 now, right? So what do we do? There is something called remappings in Foundry. So remappings basically like generate where is it? Generates a path to your files for you. So come in. Let me just search for it. Depends. Yeah, so yes, it's before easier to import. For the I try to make some reference. It makes importing of libraries or importing of packages or dependencies into your project to be easier. And how do you do that? Instead of specifying, let's say you want to like bring um, yeah, see, okay. So you want to like bring this IRC here now, right? Let's see, we don't have this right. Instead of saying import from LIB, this, what do you call it? Open Zeppelin, then you go into a contract, then you go into token and stuff. The mapping is basically like generating clear paths for you, which is like straightforward. So all you have to do is run forge your mappings. Right. So for every dependency or every library you have, it's going to generate a remapping for you. So this is the remapping, and what you need to do now is just copy this and create a file called remappings.txt and paste this in there. So if you look at your something, so you have if you want to, so you can see that this specifies like the path to LIP Open Zeppelin contract, right? So this interface is like what do we call it? The interface I defined myself earlier, right? You can see that this contract should complete now. So using these remappings now, say I want to be able to bring the IRC20 in scope, IRC interface in scope now. So I have to just specify here. We start by importing from here, right? So it stops here. So you have contracts, then you have tokens, tokens. Then PLC, PLC 20, PLC 20 dot so. So let me just build practically say like work the same. Okay, now, 20, check remarkings. A minute plus here should work out of the box. Oh, okay. Yes, so I think the path is not correct. It's appealing. It's appealing as contracts. So we should go directly to the okay. Contract. Token. Oh, it's not tokens, it's token. Should compile now. What build? Yeah, it works. So whatever. So that's like the overview about remappings. Any question on this before I proceed? Okay, I guess there are no questions then.
Yes, I don't think there are any questions.
Yes, are you saying something? So I can't hear you.
Yeah, Kelvin, can you hear me?
Yeah,
Of course. Let me
I can't hear you. Okay, I'll just continue. We're almost done with the session actually. Right. So this is how you like to bring in external dependencies into your project, so you can start like using them. So imagine you have an ERC
see.
7 to 1 contract, so you can easily like import whatever you want, and yeah, you inherit it basically. So let's so that's like the fundamental introduction to Foundry. And there are more advanced concepts you can do with Foundry. You can fork a network, you can do force testing. What force testing basically does is it's you're testing your contract with different parameters, right? And you can generate use case scenarios in your head because yeah, you are human, you're limited. So what you can do is do force testing, which like um, overloads your functions on your test with random parameters, and you are able to like test different case scenarios. Also invariant testing, and yeah, so you can do invariant testing, you can do differential testing, deploying and verifying your contract, and other things like that. So similar to HADAS, remember we already talked about gas tracking when we like run our execution to basically like say get gas reports, right? It gives us like the minimum amount of execution it takes to run our function. That's what gas reports or gas tracking basically means. Now, when you get to Anvil now gives you the functionality of like spinning up your own local blockchain, right? Just as fucking creating like a local blockchain in your hard hat. That's the same thing Anvil does for you. So you can deploy on this blockchain, you can test on this blockchain, and you can like do a whole lot of other things. Yeah. So like any questions so far before I proceed? Any questions?
Um, sir, so I have question. Can we get the repo, like the link to the repo?
To this one,
Okay, Kevin, can you hear me now?
okay, I would like create a report to this now and like send it to. Okay, let me create a repo now. I'll forward it and I'll add. I sorry for not coming with slides to the class because it's actually like a lot and I don't know how to like compress that amount of information to a slide. Rather, it's better to. So, besides this repository, there are some other contents I would like to like show us. Yeah. So I'm dropping this on the. Is it public? Yeah, it's public. I'll drop it on the call now. Please, Franklin, it's advisable you like talk because I don't have like the bandwidth of checking chat. I'm just seeing your message now. So what start prank does is it enables to like prank a person, right? Say like not a person like say you want this like the current execution of the current color of that function should be the user. Let's go back to there are a number of them, right? I just don't want to like start digging into code bases. Um, okay, let me just go to this contact dot so no, that's identity dot so. Now, one thing you have to know about Foundry is when you are running testing Foundry, the contract itself in this case is images of sender, right? But now we want user one, like we want to like make this user one like oh goodness, to make him like this color. So we have to like prank user one. So user one is the one making this call, this instance is proving this person, and user two is the person we're sending to. We have to like branch user two too. So you're sending to this amount to user two. They are certain that this the balance of user one and user two is so amount basically. So and there are other examples too. So I want to like show us the repository that is very straightforward. If you come to the section of tutorials, you can see tutorials here. I want you to like come to the section of learning Foundry with videos. So I wouldn't say well I'll say you ignore like you can um come back to this Patrick Collins course later, but I would advise you go ahead with this playlist first. This smart contract programmers playlist because it takes it from like a basic level to advanced level. It talks about introductory, then intermediate such as force testing, invariance testing, hooking the network, spinning up a local node, and things like that. How you test different functionalities. So the example we did for today's session was gotten from the repository used for the videos. So you have a number of like what do you call it projects here. How you test bits, counter errors 1.55 errors 20 errors 7 to 1, how you test for events, how you test for signatures. You get to there are a lot of things you can learn there. So I would Be pasting this. Please do well to check it out. Foundry book, this playlist on YouTube. Please, admin, could you like kindly like take note of these links, right? So you can share with them on the like whichever medium of communication you use, so they can go back to these videos and learn those concepts themselves and practice with it. So you don't need to like, I think one of the issues with learning is that we tend to like when you learn fundamental things, you want to like come up with case scenarios in your head. Okay, how do I like practice what I've learned and things? So this project contains like a number of projects, a number of test cases or um, what do you call it? Solidity contracts you can play around with. So you can just like come here, copy, say this token of soul, paste it, write tests for it, and things like that. And you can take existing projects you've written and try to write a test for them in Solidity. Do you understand? So this is the end of like this is the end from my hand. I'd like to like ask if anybody has any question so I can like put it in and we continue. Rapid. Does anybody have any questions? Okay, have we enough of questions? This is it from my video.
All right. Can you guys hear me now?
Can hear you.
Yeah. Good
Yes, I
evening.
can.
Yeah. Good evening, Kelvin. I want to apologize for joining the session late. I had another workshop beforehand. I want to say a very big thank you to you for like joining us for this class and taking walking us basically through using Starknet Foundry for testing. And I've compiled the links and I just sent them to the group chat. I don't know why a lot of persons left the call, but then I guess people are beginning to prepare for exams, and that's one of the reasons why I'm looking to ensure that we round up the boot camp by March 5th of next month, so that everybody can have time to like read for their exams. But thank you once again, Kelvin, and we really appreciate. So the recording of the call, like would be made available in the coming days. So for people that probably left, some people who didn't join the session, because an assignment is going to be following shortly. I'm going to be compiling an assignment on some of the things Kelvin walked us through today. So please try to go through the recording. Thank you to them for staying to the end, and I guess that will be it. Have an awesome day ahead, everyone.
Yeah, thank you so much for the
Okay, welcome.
opportunity. Yeah,
You're welcome.
bye.
Bye, everyone.